Welcome everyone to today's online event with MECLA, the Materials and Embodied Carbon Leaders Alliance, as we turn a spotlight onto steel. As we start today's event, I would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. I'm speaking to you from Gadigal land, and I pay my respect to elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander people participating today. My name is Hudson Worsley from Precinct, and I have the pleasure of being MECLA's chair. I'd like to welcome everybody to this spotlight event on steel, one of the most important materials in our modern world and the driver of 7 to 9% of global greenhouse gas emissions. Green steel is the focus of much research, commentary, investment announcements and media attention. So thank you for dialing in from around the country to join our stellar our lineup of speakers as we explore the journey so far and consider what lies ahead in the decarbonisation of steelmaking. Spoiler alert, it's very complex, capital intensive, it will take time, and it comes with its own alphabet soup of acronyms, so we'd all better pay attention. As the grandson of a metallurgist who worked at BHP Newcastle coke ovens making steel all his working life, I'm particularly excited to hear from our speakers today and what the opportunities are that lie ahead. Before we press on, as with all MECLA events, I'd like to remind everyone of our governance framework. Our collaboration comes together to drive reductions in embodied carbon in the building and construction industries. We seek to align with the Paris Agreement targets and the principles of the circular economy. We must all remain vigilant to avoid conflicts of interest and any anti-competitive behaviours. And this is just so important to maintain the legitimacy of our collaboration. Please note that we will be recording this event, and that recording will be available to anyone who's registered afterwards. Please mute yourself. Please put your full name in the Zoom label so we know who you are, and use the chat function for questions, which we'll field later on. All right, so today we'll be hearing from 4 speakers, all with deep industry experience. Hayley Jarick is the CEO of the Supply Chain Sustainability School, and she'll set the scene and provide an overview of the complexity of decarbonising steel and manufacturing. Hayley is also the chair of MECLA's working group on steel, and so is really contributing to this discussion. Greta Stevens, our second speaker, is the Chief Executive Climate Change at BlueScope, and she'll talk about BlueScope's decarbonisation pathway, enablers and climate action. David Bell is Manager Sustainability and Insights at InfraBuild Steel, and he'll tell us about InfraBuild's carbon neutral journey through the use of electric arc furnace, key drivers and where to head from here. Jeff Oatman is the Head of Collaboration and Membership at the Green Building Council of Australia, and he'll talk to us about how the GBCA is driving demand for low carbon steel. Our speakers will then join Joe Carton from Built, who will lead a panel discussion. So lots to talk about, lots of expertise. So let's get underway. Hayley Jarick, can I please hand over to you?
So I'd also like to begin by acknowledging the traditional custodians of lands on which we're all joining from and pay my respects to their elders past, present and emerging. I'm joining from Gadigal country today as well. And I'd also like to start off by giving a bit of disclosure about me. So for those of you who don't know who I am or my background, Hudson said I'm the chair of the MECLA Steel Working Group. I'm also the CEO and Company Secretary of the Supply Chain Sustainability School. We are a membership association, and our fellows include the likes of BlueScope, InfraBuild, WWF, Lendlease, GECA, and Responsible Steel, who will all sort of be mentioned throughout the conversation. I'm also a director of Responsible Steel. I'm a former employee of BlueScope. I chair the Planet Ark's ACE Hub for Procurement Working Group. I'm also a scout leader, and I teach lots of little joeys from 5 to 7 years old all about the environment and working through things. But I'm also a sister, I'm a daughter, I'm an auntie, I'm a wife, and I'm a mother of 2. So that gives me a pretty rounded perspective on a lot of things, but hopefully that gives you a bit of disclosure about me and why I, of all people, I'm here giving you you a bit of a roundup on what's happening in the steel so far today. Now, I am trying to try and summarize like 100 years of steel making and a year's worth of MECLA groups in about 20 minutes. So I apologize for moving through this fast. Sit back and relax. All of this is being recorded. You can always go back and watch it later and think, oh my goodness, Hayley, I can't believe you got through all of that in that short amount of time. And I'd like to openly apologize to all metallurgists watching today. I'm going to blatantly summarize your life's work in a very short amount of time. Please don't take any offense. I'm just trying to keep it on one level for everybody. The MECLA Steel Working Group has put together a document with all of this information in there that will be available with this video after the event as well. But I'd like to first begin by sort of going back to basics for everybody in the room and sort of going, well, what is steel? So for those of you, you might be more familiar with sort of the end products of steel, or how it might look on your roof or in the walling of your business, or in the way that you construct through the industry. So most people are familiar with things like rebar and steel sheets, and also sort of the structural purlins as they go through. But this is how it all comes together and is being made. So this is a bit of a summary of all the sort of steel production routes as they operate around the world. I'm sure that Hudson alluded to, there's lots of acronyms in this place. So look, if you're looking in the middle there around iron making, there's the blast furnace, they often call that the BF. There's direct reduction technologies as well, and DRI, so that's obviously direct reduced iron. OHF is open hearth furnaces, BOF is the basic oxygen furnace, EAF is electric arc furnace. But basically the way that this works is that you get your raw materials, you then produce iron with those, either from a blast furnace or direct reduction, and then you convert the iron into steel through a steel making process of either mostly BOF or EAF production. To give you a bit of a summary of that, about 70% of the global production is that blast furnace BOF steel making route. And if you're looking at sort of the inputs ratio, 1 tonne of steel or 1,000 kilograms of steel, you need to get about 1,370 kilograms of iron ore, 780 kilograms of metallurgical coal, 270 kilograms of limestone, and 125 kilograms of recycled steel. And you can get that up to about 30% of the end capacity in that space. And like you said, basically you take the iron ore, you reduce it to iron in the blast furnace, then the iron is converted into steel in the BOF. After that, they cast it and they roll it and do all the sorts of wonderful stuff to it and coat it that makes it look like the things that you see at the end of the pipe today. In Australia, you're looking at BlueScope make this in Port Kembla, Infrabuild make this at Whyalla. About 30% of the market of global production is around electric arc furnace steel making, where basically there's a lot of recycled steel goes into the electric arc furnace, and that can be up to 100% recycled content. If you're sort of wondering why you wouldn't always put 100% recycled content in EAF furnace, a couple of reasons for that. One, you might not always have the right grades and right amount of scrap to be able to do that. But also there's sort of an energy play-off in this as to how to reduce it. So the way it was explained to me that I always remember is if you get 2 mugs and fill them both with ice, and you put 1 mug in the microwave and see how long you can get it to convert back down to liquid, and then you get the other mug and pour boiling water over it first, and then put that in the microwave and try and reduce that down to liquid. You use less time in the microwave with the one that's covered in boiling water because the coating around all of the ice and the temperature reduction melts the recycled scrap faster. And so there is some synergies and technologies and energy reduction available when you use a combination of hot metal and recycled scrap in order to reduce it down to a liquid again to keep going forward. And of course, EAF in Australia is produced by Infrabuild. So in terms of the technology, obviously, when you get iron, you combine it with carbon and recycled steel and small amounts of other elements in there, it becomes much stronger, and that's why we change iron into steel so that we can use it and make it stronger. It can be up to 1,000 times stronger. And this process of basic oxygen steel making, or blowing air or oxygen into the steel, has been around since about 1850s by this young chap on the screen, as around sort of blowing it into the molten pig iron to oxidize the materials and separate all of the impurities. Now those impurities, you might another name for that is slag, or other things that pop out of it through the process. But through that whole process is relatively efficient. Obviously, all of these things cost a lot of money. So over those sort of 100 years of production, we found really good ways of converting a lot of that through. So in terms of raw materials to end product, you know, there's a pretty high ratio there of converting those raw materials into end product, primary product use, but there's also 30% of that were converted to co-products. And those co-products are things like slag, processed off gases, emulsions and oils, iron oxides and zinc and chemicals, and they're all used in different industries around the world. And we call them co-products because they're usually sold off in that space. It's not necessarily something that is a commodity and can be used in different areas, with only about 3.7% on global average of that becoming waste, as you would need to treat and dispose of. There's also been a lot of efficiencies in the industry over the past sort of, you know, from the 60s, so the past sort of 50 years or so, really reducing the amount of energy that's being used in the process. So on average, dropped from about that 60 gigajoules per tonne down to about 20 gigajoules per tonne. And of course, when I say, you know, it's live to have that lovely bar across the bottom of that screen that says what crude steel is, but you know, that's a very simple definition of what is a very complex product. You know, there are over 3,000 different types and grades of steel, and they're all used for different purposes. So some grades are more malleable than others and can be rolled and shaped. Others are more sturdy and strong. And that is sort of how it processes through as to what you need. There's a lot of technology and development, like R&D, that happens in this space. So of those 3,500 new, you know, grades that are out there, 75% of them didn't exist 20 years ago. And there's also a lot of work happening around in this space around, because recycled steel is a constant component of making either type of steel. So whether you BF, BOF and up to 30% steel scrap, or you're in an EAF where you're up to 100% scrap, you still need steel scrap in order to make steel and reduce iron down into steel. And it is a permanent material. So you can actually take steel and, you know, you could take your roof, put it back through the process, come back, and that same piece of steel can be your roof again. And so in that respect, from a circular economy point of view, like Hudson was saying, it is sort of infinitely recycled back into the same purpose. So it doesn't need to be, it can be upcycled, but it doesn't have to be downcycled in that process. It can come back and do the exact same process again without any loss of quality. And of course, the success of that cycle coming back through is really around the recovery rates of steel in the industry. So while steel is theoretically 100% recyclable, it's around being able to capture all that steel at end of life. That's one of the big processes. Electrical and domestic appliances are probably the worst recovery rates. Machinery and automotive are great, and construction's 85%, so could probably do a little bit better around recovering the steel from that process as well. So now we get up to the issue of meeting one MECLA Steel Group. This is the issue that we were sort of thrown in to try and get there. And Hudson set this up for us at the start. The iron and steel industry contributes about 7 to 9% of the global greenhouse gas emissions. So if we're going to produce a sustainable future, the industry must find ways to cut emissions in line with those international goals to limit climate change. And that's because for every tonne of steel produced, there's about 1.8 tonnes of CO2 emitted. And the majority of that CO2 comes from the chemical reaction of making steel. So sometimes a few people get this confused, where this might just be the, you know, is this CO2 from the electricity used in order to use in the process? A lot of this comes from a chemical reaction rather than sort of the use of electricity, and the electricity is the process that's actually emitting the carbon. But the industry is working together to cut down on all of these emissions, and sort of looking at new technologies that can really cut that chemical process down. And we were talking a little bit about those, which then takes us onto the conversation of, well, then what is green steel? And of course, it has, you know, it's a very controversial topic. Does it mean low embodied carbon? Does it mean you know, near zero embodied carbon? Is it net zero embodied carbon? Is it 100% recycled content, 100% reused content? Is it ethically sourced, responsibly sourced? Is it greenhouse gas emissions that are offset? Is it greenhouse gas emissions that are avoided? Does it mean 100% renewable energy? Or does it mean that your steel has an EPD or an eco label? Or is it steel that is just like quite literally painted green? And the short answer is it's all of the above. Because there is no commonly used definition of green steel. And the only way to truly find out what somebody meant when they said green steel is to ask them what they meant when they said green steel. And this is probably true of most green claims that are out there in the industry, but especially in this space that is so diverse into how many different sustainability initiatives are available for different types of steel. So it's best just to go and ask the source, what did you mean when you said that? And so as we came into the group and we sort of sat there and we got to this point of going, okay, right, so there's no definition of green steel. We've got to cut these emissions. We're a demand side group trying to produce this. Well, why can't we just stop making virgin steel today? So what if we only made net zero steel with 100% recycled content that uses 100% renewable energy? This is like the purest form in there. What if everyone just specified this and we all went there today? And the answer is a little bit complex, but I'll try and explain it as simply as possible. So for those that are looking and remember this map that I put up at the start, this means cutting out all this left-hand side and literally just sticking with this right side of just recycled steel, electricity going into an EAF. And it's sort of a two-part answer. The first one is around, well, because of the demand for steel. So if we're looking at sort of population growth since the 1950s, population has grown quite considerably, and this has increased the demand for steel in general. Combined with that is that all of the technologies and initiatives that people are putting forward in order to try and reduce carbon emissions usually involve steel. So if you're talking wind farms, solar farms, mass transport options, even, you know, introducing sort of all of the transport around cars and buses are all lighter, stronger. You know, if you have a really high strength and advanced steel, you can use less steel in a building. If you're using sort of high strength steels in buses and transport options, then you can actually reduce the emissions that are in the use phase of that that bus throughout the lifetime, because it's lighter, therefore it uses less fuel to get that bus around. And because of all of this, you know, the steel industry is investing sort of 8% of its revenue in these innovative steels to try and develop this in the marketplace and sort of grow those types of steels in that market. And because of that increase in demand, production has also increased. So this is the world steeling figures from this year, so 2021. And this shows the map of production since the 50s around how much steel is being produced out there in the world. And they also predict that by 2050, production will go up by 20% again. And so the short answer is the future expansion of the scrap-based steel production route is solely dependent on the availability of those high-grade scraps in order to meet the demand that we've just seen. Now, I did speak before about steel is the most recycled material in the world. It's magnetic, which makes it easily separable. But, you know, fun fact for everybody, we all have about 228 kilograms per person per year of steel in use every year. And the reason why that is because steel has such a diverse but long use phase before it becomes available to be recycled again. So all things that you can make out of steel range from everything from a couple of weeks from a tin can that you might buy off the shelf. You might spend 15 or 20 years in your car before it'll get scrapped and can be heard back around again. Or if you look at things like the Sydney Harbour Bridge, you know, there are hundreds of years in production before that steel then come back around to be available to be scrapped and recycled again. So the average of, you know, between the 2 weeks and the hundreds of years is about 40 years from when steel is made as to when it becomes available to come back around to be used as scrap in order to be used in that process to make more steel. And so the global forecast for the end of scrap and life and availability is this. So this is where we sort of see everything that has been made and when it will become available on the market again. If we look at today and the amount that is available sort of in 2018, you know, when they mapped this map out, it's sort of around that 390 million tonnes, and 2030 we should have about 600 million tonnes available to then use in those scrap making facilities. But of course, if we sit there and look at the end of the day of the demand and we go, well, is that enough to meet demand? If we used 100% of that scrap availability back in fully EAF furnaces right now, could we make all the steel that is available? And the short answer is no, we can't. So this is the IEA put out this iron and steel technology roadmap and actually showed there the amount in blue is the end of scrap availability, the production from those that they forecasted out to FY 2050. And then the red is what we still need to make from iron ore production. So that's that, you know, like the blast furnace BOF route. We still need to have those iron ore reducing technologies in order to meet the demand for the amount of steel that we need so that we can keep up with the world population growth and the demand for steel for all of the technologies we need in order to enable a low carbon future. The other thing to keep in mind is that not all scrap is created equal. So there's different grades of scrap. There's really nice, pure stuff that comes like offcuts from the steelmaking process. And then there's the post-consumer recycled scrap, which is your fridges and things like that that come back, which obviously have impurities in them. And you can't use an EAF furnace for all types of steel production. So the type of steel that you may need in your project might just not be capable of being made via an EAF route at the moment. And so there's a couple of things happening in that space. There's obviously technological improvements in this space to try and improve the amount of, the technology that we can use and the type of production processes we can use in order to increase the amount of scrap use in an EAF furnace. But also, we have to really carefully manage, there's a quality control process here as well, in that ensuring the steels we are producing are prime so they're not scrapped early and shortening their lifespan as well. So then, of course, the next question comes along, which is, well, hang on then, is it just in better if we're going to produce this, we're a demand side organisation, would that encourage all of the Australian steel producers to reduce their carbon emissions? If I can't get it in Australia, I'll import it. For my project, I want to get the lowest greenhouse gas emissions possible for my project. If I just imported that from overseas, if Australia can't make it, will that then incentivise the Australian producers to change their ways and all of a sudden reduce their greenhouse gas emissions? Which is a fair question to ask. And the short answer is we'll just go through from a couple of, let's put Australia on the map in terms of world steel production. So there's still that global steel production that needs to be made. Let's see how much of Australia isn't a major player in that. So Australia and New Zealand make about 0.3% of the global production of steel. And if you look on that little diagram on the right there, the majority of it is made in China, and we're sort of one of the others in that, I want to say like vomit green box at the top. And then if we rank Australia in the list of, where we're at, where Australia's down there, number 29 ranked in the list of production. We make a good 5.5 million tonnes a year of crude steel, which is that coming out of that steel making process at the end there. So we're a relatively small player in the global sense of things in terms of how we can then influence the way that global steel production is made. So in that sense, it means that we're fairly limited in the technologies we can then also invest in, and we used to be able to maximise the assets that we have. If you're spending a lot of time, effort, and embodied carbon inputs into production facilities that are supposed to last 20 years and you only use them for 5, that's not a sustainable outcome from especially from a whole of life and circular economy point of view. So we want to be able to maximise assets and then upgrade them when we have the chance to be able to upgrade them in technologies that are fit for purpose at the time. And I'm sure that both InfraBuild and BlueScope will speak to their own technology limitations and capabilities directly after me. But this is a concept that I want to spit out there for everybody, is just around that, should I import? And this is essentially what happens if you choose to import a low greenhouse gas emission steel for your project globally around the world. So this is my lovely map of the world. Someone over in Europe has made some relatively low greenhouse gas emission steel, a little bit smaller balloons than what would be produced in Australia. So that my project comes along and says, great, well, I'm going to import that lower greenhouse gas emission steel into Australia. And then the 5.5 million tonnes of steel that are made in Australia aren't just going to be sit around and scrapped. They're going to be sold. And if they can't be sold in Australia to projects, then what they're going to happen is they're going to export them somewhere overseas to be made. And effectively, both of those transport routes then gain additional carbon. And so what happens in this mix is that there's the overall shift around, like did it actually encourage or change any behaviours in Australia? No. Did it offset or encourage anyone in other countries around the world to encourage their production? Well, no, they're very much limited by technology as well. But what we may have done is actually increase the global emissions from the transport factor and burden shift, and not only just from the primary product, but we now have to ship scrap around the world to try and manage these products as well. So if I tried to demonstrate that in sort of another way, just to sort of, for those that don't like the map and arrows, this is my palace that I'm building in Australia. And I want to try and make that really low greenhouse gas emissions as possible. And my ring of burden that I'm going to put around my project is just around my building. I want my building to be really low GFC. And I'm pretty happy about that because I've imported some really low greenhouse gas emission steel into my project. So at the end of the day, my building looks sweet. But then what happens around the world is, well, I've actually increased the amount of balloons that have gone up globally. So from a global front, it might not be perfect in there. So the short answer is it better to, the question of, is it better to import low greenhouse gas emission steel from into Australia or overseas? It's basically a carbon accounting question. It's not necessarily a global emissions question, and it may be yes for your project, but probably not for the globe. And so us as a group were then sitting there and going, well, that's great, Hayley, but that's really pessimistic. So what will actually help? And so don't worry, we got to that bit as well. So now we've sort of explained to you where we got up to. There are a few organisations that are doing great work in this space. Obviously, I've used a lot of material from World Steel, and they are doing a lot of work in this space around reducing their emissions and starting a lot of programs. The Responsible Steel is also, they're the first sort of global multi-stakeholder standard and certifying initiative. They've got 12 principles that include climate change and greenhouse gas emissions, but they also include other types of sustainability measures within their standard, like biodiversity, human rights, labour rights, and everything else included in that. But both of those organisations are part of the Net Zero Steel Pathway methodology project as well, which is actually looking at science-based targets based on the Paris Agreement in order to try and reduce those global emissions, and really looking at those technology pathways for both the EAF and blast furnace BOF routes in order to reduce their emissions. So on that BFBOS front, medium term, look, there are greater use of affordable, reliable, renewable energy in that mix. They can do, they can increase scrap usage up to about a 30% limit. They can optimize the raw material mixes that they have. They can capture and reuse greater proportion of waste heat and gases, a lot of which already do in integrated steelworks. So on that graph before, there's a lot of natural gas inputs. A lot of those steelworks will actually use a lot of the off gases from processes as a substitute for natural gas and do the closed loop recycling inside the actual the production setup. They can capture and reuse greater proportion, sorry, I said that one, replace the proportion of coal with alternative reductants like biomasses and hydrogen containing gases. Future technology that is still sort of yet to be proven in commercial levels are around, you know, like carbon capture technology, or using electrical energy through an electrolysis basis to provide, to reduce the iron ore, or substituting hydrogen for carbon in iron making that would generate H2O or water rather than CO2 as the chemical component and output. I think that's the sexiest part that most people have heard about in future technologies as we're coming into sort of that green steel area of what's happening. From a policy perspective though, you know, ensure affordable and reliable low emissions energy supply is a key one. Establishing green hydrogen supply chains is a key policy outcome that would help. You could co-invest in the steel industry for abatement projects and also support research and development in this space. And of course, sort of ramping home, nearly finished. Sorry, I know I've been talking pretty hot off the trot as we come through. I'm just waiting for my slides to catch up. From a demand side perspective, there are a few things that you can do and that we have included in our brochure as well. So you could consider climate change commitments of the steelmaker and ask them to see their decarbonisation pathways and targets. You can support the manufacturers who are transparent, so those look at the steel that has an EPD or an environmental product declaration. Specify steel from manufacturers who are certified and credible with schemes like Responsible Steel. You can understand the role of primary and secondary steelmaking in meeting the overall steel demand and their differentiated decarbonisation pathways via the Net Zero Steel Pathway methodology project. So that's sort of just saying, you know, helping EAF furnaces that are working on EAF production processes and supporting blast furnaces, BOS processes that are actually on that decarbonisation pathway as well. You can support manufacturers who are participating in emissions reductions research, like the World Steel Step Up program and Australian Industry Energy Transitions Initiative, and also consider offsetting as part of the broader program of decarbonisation with products like climate active certification. And of course, I alluded to before, as the building and construction industry, we can always increase that recovery rate of steel from 85% up to 100%. And that's something we can all do in-house and focus on. And this is a personal one from me and a request to everybody out there as well. There are a number of organisations already doing work in this space. So if you have the means, the time, the money, please support the organisations that are already working in this space with your membership and following along. So if you haven't already, join MECLA. And then look to the other organisations that you can support in this space, like join the Green Building Council of Australia's work in decarbonising the building industry, work with the Infrastructure Sustainability Council around decarbonising the infrastructure space, become a member of Responsible Steel if you're looking to get involved with steelmakers globally and support that global initiative. And of course, I wouldn't throw away money for anyone who wanted to join as a fellow of the school to help educate people as well. But please jump out there and get involved with people who are already making a big change in this space. And that's me done. Hudson.
Wow. Hayley, thank you. That was rapid fire and that was a lot of information, but terrific to hear that there are positive steps that we can all take, and also some of the nuance around the complexities of potential unintended consequences in seeking to do the right thing from a carbon perspective. It ain't that simple. So thank you for setting all of that out.